Let's take a look at graphs of the tangent, cotangent, and secant functions. Now, if we're my pen to work here, there it goes. If we're talking about cosine, sine, cosecant, and secant, our period is going to be 2 pi over b. And if we're talking about tangent and cotangent, our period is going to equal to be pi over b. Well, let's take a look at what tangent looks like and cotangent. It's kind of good to have that in mind when you first start graphing, and so you know what to expect. Okay, so I'm going to press y equals, I press clear, put in tangent, and then push my X key. You can put a closing parenthesis if you want, but if I go ahead and press, let's see, I want to press mode, and then make sure I'm in radians, which I am. But if you're not, then down arrow to that line and press enter on radians, and then we're going to choose zoom, and choose Z-trig, number 7. And that's what tangent looks like. Okay, now let's look at cotangent. Remember, cotangent is 1 over tangent. So I'm going to down arrow to y2, and I'm going to do 1 divided by tangent, and then put x in, close parentheses, and then graph. There's the tangent didn't redraw, but there's cotangent. You see it has the same general flow, except for it's flipped around. It's reflected. So keep that in mind as we look at this first problem. Okay. Okay, so we got y is equal to 2 tangent of 1/4 x, like that. Now the b is what's before our x here. So our period is going to equal to pi over b, so pi over 1/4. Now if you got a single fraction, you flip it and multiply it times your top part. So we got pi times 4 over 1, which gives us 4 pi. Okay, so let's build our t-chart. Now always this first value is 0, like that. And let me scroll down a little bit there. This last one is always our period, which is 4 pi. In the middle here is half times our period, so half of our period, which is 2 pi. This is a quarter of a period right here, which is pi. And you kind of see a pattern what they go by: 0 pi, 2 pi, so this is 3 pi. But the formula for it is that it's 3/4 of our period. And you're just multiplying there: 3/4 times 4 pi, 1/2 times 4 pi, 1/4 times 4 pi. Okay, so over here, this is going to be our y values. We got y is equal to 2 tangent of 1/4 x. So where the x is, I'm going to plug in these values. So I got 2 tangent of 1/4 times 0, which gives us 2 tangent of 0. This one, we got 2 tangent of 1/4 times pi, which gives us 2 tangent pi over 4. Here we got 2 tangent, and we got 1/4 times 2 pi, which is 2 pi over 4, which gives us pi over 2. Okay, and this one we got 2 tangent 1/4 times 3 pi, which gives us 2 tangent 3 pi over 4. And then this last one we got 2 tangent 1/4 times 4 pi is going to give us 2 tangent and the 4's cancel of pi. Okay. Let me bring up a unit circle just so you can see how I get the values. Remember, tangent on a unit circle is y over x. And, well, actually, maybe I can just do it here. Okay, so here's 0, our first place. And again, if you're not comfortable with the unit circle, look in unit circle to see this. Tangent is y over x. Well, y at this position is 0. So we got 0 over 1, which is 0. So we got 2 times 0, which gives us 0. On this one, we got tangent of pi over 4. Well, the pi over 4 is right here. And the point is a square root of 2 over 2 and square root of 2 over 2. This one is 1, 0. So we got y over x. Well, square root of 2 over square root of 2 over 2 gives you 1. So 2 times 1 gives us 2. Now here, I got tangent of pi over 2, which is right here. And this would be 0, 1. Y over x. Y over x, that'd be 1 over 0, which is undefined. Okay, then this one. Tangent of 3 pi over 4. I'm over to here. It's still square root of 2 over 2 and square root of 2 over 2. Difference here is the x value is negative. So I got y over x, so this over this. Of course, they're the same, so that gives you 1. The pi over 4 is 3 pi over 4, 5 pi over 4, 7 pi over 4. They're always going to be 1. It's just the sign is going to vary. So this will be negative 1, which gives us negative 2. And back to the beginning, so to speak. We got negative 1, 0. Y over x, 0 over negative 1 is 0. Like this. Now, unlike sine and cosine, this is going to go from 0 to pi over 4 to pi half to 3 pi over 4 to pi. It'll always follow that form if you pick your period right. Okay, so now we got some points to plot. So let's come down here. Looks like 4 pi is a maximum there. Okay, so I'll put 4 pi here. Now pi is like 3, so this is roughly 12. Here's 2 pi. Here's pi, and here's 3 pi. Actually, pi might be a better one to look at. Pi is like 3. No, this here is about 3. It goes up to 2 and negative 2. Well, if this distance here is about 3, then 2 is about, I'd say, that distance. You want to keep the proportions fairly good on these, because otherwise they'll come out looking exactly the same. Then put negative 2 here. Okay, scroll up. Our first point is 0, 0. Zero, 0 is right there. Our next one is pi 2, which is right here. Our next one is 2 pi undefined. Well, what undefined means is we have an asymptote here. We have a vertical asymptote at 2 pi. Means your graph's going to skim it at some point, but not touch it or cross it. Now 3 pi. 3 pi was negative 2. So I go to 3 pi here, and negative 2 be right there. And then 4 pi was 0. Okay, now if I kept on going with this, this would be 5 pi, and this would be 6 pi. Well, it repeats. See how it starts here, then goes up to here, then it's undefined, then it's down here, and then it's back to the starting place here. So this right here would be right here. I don't even need to plot any points. I know that's how it's going to go. And then this is going to be undefined. Because again, what follows this point is undefined, so what follows this point will be undefined. Now this would look like a straight line. You just draw a line through it if we didn't already know what the picture is roughly going to look like. And I don't freehand these very well, but if I go ahead and connect these points together, that would be what our graph would look like. Now it repeats, so here this one would be, let's see, right about right there. Then this would be the undefined, like that. So it's going to go up like that. And that would be your answer. Hate to do like one problem per page, but let me, it looks like I'm about out of room there. So let me save this. Okay, so trig graphs of tangent, cotangent, and secant functions. Page 01. Okay, so let's start a new page. And look at the next problem. Okay. Cotangent. We got y is equal to 3 cotangent of pi over 2 x. I didn't find a domain and range of the other one, but I think that's I'll find a domain and range of this because it isn't self-evident, I don't think. Okay, so first thing we need to do is find our period. Now our period is going to be pi over b, and b is whatever number's before your x, so this is going to be pi over 2. Again, if you have a single fraction down denominator, you can flip it, take the reciprocal of it, and multiply it times the top part. The pi's will cancel, and we got 2, so that's our period. Okay, so we'll build our chart here, t-chart, and we got 2. Oops, sorry, this is 0. 2 down here. That's our period. This is 0. Right here is half our period, which is 1. Here's a quarter of our period, which is 1/2. And here's 3/4 of our period, which is 3/2. Now we're going to plug these values in here. So we got 3 cotangent pi over 2 times 0 equals 3 cotangent of 0. Here we have 3 cotangent of pi over 2 times 1/2, which is 3 cotangent of pi over 4. Here we have 3 cotangent of pi over 2 times 1, which is 3 cotangent pi over 2. Here we have 3 cotangent of pi over 2 times 3/2, which is 3 cotangent of 3 pi over 4. Okay, and this one is 3 cotangent of pi over 2 times 2. 2's cancel, and we got 3 cotangent of pi. Now notice, these are exact same values we had on the last problem. That's just not a coincidence. If you pick your period right, you're going to find these will go back to these main points right here. Now these are the specific ones for tangent and cotangent. We're going to see cosecant and secant have their own. Okay. Now remember, cotangent in terms of our unit circle is x over y. So here we are going around our unit circle. We start off at 0 here. This point here is 1, 0. X over y. Well, x over y would be 1 over 0, which is undefined. So that's undefined. Now this one is pi over 4. Here's pi over 4. And it's square root of 2 over 2 and square root of 2 over 2. Well, x over y. Square root of 2 over 2 over square root of 2 over 2 gives us 1. So we got 3 times 1, or 3. Cotangent of pi over 2. Right here. This would be 0, 1. And we have x over y, so put 0 over 1. That gives us 0. So we got 3 times 0, or 0. On this one, we got cotangent of 3 pi over 4, which is right here. And again, this is square root of 2 over 2 and square root of 2 over 2, except for the x is negative here. So x over y, of course, square root of 2 over 2, square root of 2 over 2 all over square root of 2 over 2 is just 1. And this is negative, so it's a negative 1. So that gives us negative 3. And on this one, we're over here to pi, and we're back to the starting place, undefined. I guess I ought to erase that then. But the reason why is this is negative 1, 0, and x over y. We'd have negative 1 over 0, which gives us undefined. And that's actually all we need to graph it, because we have a general idea what they look like. So let's go plot these points. Now my period is 2, and then it goes up to 3 and down to negative 3. So keep that in mind. Okay, so if I try that again. Let's say that's 2. So this distance is 1. So then up here, this would be 1, 2, and here is my 3. Then down to here, this would be negative 1, negative 2, and negative 3. And that'd be my 1/2, and that'd be my 3/2. Okay. First one, at 0, it's undefined. So let me scroll back down. Undefined. I'll put little dots up here at the top and down at the bottom to indicate it's undefined there. That's an asymptote. That's a vertical asymptote. It means it'll skim at some point. Then our next one is 1/2, 3. So I got 1/2, 3. Next one should be 1, 0. Yeah, 1, 0. Next one should be 3/2, negative 3. Which is right here. And then at 2, it should be undefined again. There we go. Okay, now I know generally what it looks like, so now again, I don't freehand these very well. This comes like that. And obviously I do it really bad. I wonder if I can do that again. Let me try that one more time. Okay, so it should have a curve to it. There, that's better. That's still not perfect, but that's probably as good as I'm going to get it. And of course, I don't have my scale quite right, but still don't like that. Let me try one more time. Okay, so it's like this, and then like that. Okay. Well, that's as good as I'm gonna get it. We generally, that's why I showed you those graphs to begin with. I'm not very good at these, not freehanding them. Now, if I do more points, I could get a better graph, but anyway, you get the idea. And then it repeats. So I come over here. This would be up here. And then the next one here would be down here. The next one here would be down about right there. And then next one is our asymptote. So again, it looks like that. It's not as straight as what you're seeing there. It has more of a curve to it, but we'll go with that. Okay, so that's our answer. Let me save that. I did so good on that first graph too. I thought that looked pretty good. I don't usually freehand them that well. Usually they look like what you just saw. Okay, now let's I think the next ones are cosecant and secant and so forth. Yeah. So the next ones are that. So let's talk about just in general what the graph looks like. Again, it helps to know what it looks like before you begin. Now I can usually freehand these pretty good, so I'll go ahead and do it. And pi over 2 and 3 pi over 2. This distance here is about 3, so 1, let's say, is right there, and negative 1 would be right there. Okay, if I look at sine, sine is going to look like that. So that's y is equal to sine x. Now cosecant. Remember, cosecant x is equal to 1 over sine x. And sine on our unit circle was the y values. So our y is equal to 0. Cosecant's going to be undefined because we'll have 1 over 0. Well, it's equal to 0 here. So it's undefined there. It's equal to 0 here. Wherever it crosses the x-axis, it's undefined. And it crosses here. Like that. Now there's a reciprocal nature to these, how sine and cosecant go together. See how this one comes up to a high point of 1 and then just goes back down? What cosecant will do is it'll come down, not that fast. Okay, it'll come down like that, it'll touch at that point, and it'll go back up like this. Those are asymptotes, so it'll skim those but never touch them or cross them. This will do the same thing. I forgot to talk about the domain and range in that last one. Oh well, I'll talk on this one. Okay, like that. So that blue would be our cosecant. Now, secant's going to do the same thing, but it'll put it in reference to cosine. So keep that in mind. Cosecant and secant will look like these. Okay. So let's graph our first one. Okay, so we got y equals 5 cosecant of 4x. Let me grab a drink. Okay, let's find our period first. Our period for cosecant is 2 pi over b. And b is numbers before x, which is 4. So we got 2 pi over 4, which gives us pi over 2. Okay, so we got our x and our y of our t-chart. This is always 0. Clear down here is always our period, so that's pi over 2. Now, this is 1/2 of our period, which would be pi over 4. And this is 1/4 of our period, which is going to be pi over 8. And then this will be 3/4 of our period. Went from 0 to pi over 8 to 2 pi over 8 to 3 pi over 8 to 4 pi over 8. Okay, and then I'll plug in those values in here. So I got 5 cosecant of 4 times 0 gives us 5 cosecant of 0. We got 5 cosecant of 4 times pi over 8, which gives us 5 cosecant of pi over 2. We got 5 cosecant of 4 times pi over 4. 4's cancel, and we got 5 cosecant of pi. And we got 5 cosecant of 4 times 3 pi over 8, which gives us 5 cosecant of 3 pi over 2. And then down here, we got 5 cosecant of 4 times pi over 2, which gives us 5 cosecant of 2 pi. Now, just like when we were working with sine and cosine, if you pick your period correctly, these will always go back to these. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, here's our unit circle going around here. This point here is 1, 0. This point here is 0, 1. This point here is negative 1, 0. This point here is 0, negative 1. Okay. And cosecant is equal to 1 over y. Okay, so here at 0, we got 1 over y. Well, y is 0, so I got 1 over 0, which is undefined, so this is undefined here. Now this one, I got cosecant of pi over 2, which is right here, and we got 1 over y. Y here is 1, so we got 1 over 1 or 1. So that gives us 5. And what am I doing? Okay, there we go. This one, we're over here at pi. We got 1 over y. Y is 0, so 1 over 0 is undefined. Like that. And on this one, cosecant 3 pi over 2, I'm down to here. We have 1 over y. Y is negative 1, so we got 1 over negative 1, which is negative 1. So we got 5 times negative 1 gives us negative 5. And we're back here to 2 pi, and that's undefined again. And normally this wouldn't be very good. It's like, wow, I just got 2 points. But since we know what the graph's going to look like, that's all we really need. Okay, so our period is from 0 to pi over 2. And pi over 2. Let's put it right here. That's like 1.5. Okay. So, which means that that distance would be about 1. So, we got 1, 2, 3, 4, and 5. And negative 1, negative 2, negative 3, negative 4, and negative 5. Using your imagination. So I know that's not quite perfect. Okay, and then plotting our points. This is going to be pi over 4. This will be pi over 8. This will be 3 pi over 8. Okay, at 0 it's undefined. So right here is undefined. It means it's a vertical asymptote. At pi over 8, it's equal to 5. So here's this one was pi over 8, and it's equal to 5. Then my next one is undefined. That should be a straight line. Like that. My next one is 3 pi over 8, which is negative 5. So here's 3 pi over 8. I come down to negative 5, and I put another point. And then my last one here, pi over 2, was undefined. Now this would not be enough to actually graph it if I didn't already know what it's going to look like. I know this is going to come down, touch at a point, and go back up. So that's that part. Now down here, this would also do the same thing. Touch at a point and go back down. If you miss your point, make your point a little bit bigger. Had a professor call that the big dot theorem. This is just sketching. If you want precision, you go to a computer system and do it. Get some kind of plotter and so forth. Again, now it's important you try to make these proportional. You know, here's pi over 2, that distance, which is 1.5. Well, 5 has to be about that. You can't have 5 down here. Not without just skewing the graph. So let me save that. And we'll take a look at the next problem. Time for my little tablet to blow up. Try it again. There we go. And let's take a look at this one. We've got y is equal to 2, negative 2, secant pi x. Okay, let's find our period first. Our period is going to be equal to 2 pi over b. B is numbers for x, which is pi. So I got 2 pi over pi. Pi is going to cancel, and we've got 2. So create our t-chart. This is always 0. This is always our period. This is 1/2 of our period, which is 1, and this is 1/4 of our period, which would be 1/2. Didn't I just work this one? Pi over x. No, I guess it wasn't. Maybe, I'm not sure which one it was. It was like that. Oh well. Never mind. 3/4 period. That'd be 3/2. You just look real familiar. Okay, then I'm going to plug it into my trig function there. So I got -2 secant. I mean, I did work these, but I'm not sure where it's at. Pi times 0, which gives us -2 secant 0. We got -2 secant pi times 1/2. Again, plugging in each one of our x values, which gives us -2 secant pi over 2. Plug 1 in here. We got -2 secant pi times 1, which gives us -2 secant pi. And we got -2 secant pi times 3/2, which gives us -2 secant 3 pi over 2. And last one, -2 secant pi times 2, which gives us -2 secant 2 pi. Again, they're going to go back to those 5 key values. Sorry, I had to get a drink. Now, to refresh your memory, this point here is 1, 0. This one's 0, 0, 1. This one's -1, 0. And this one's 0, -1. Secant is 1 over x. Okay, so at 0, right here, we got 1 over x. X is 1, so we got 1 over 1. So it's -2 times 1, or -2. The next one, pi over 2. So right here, we got 1 over x. X is 0, so we got 1 over 0. This is undefined. This one's pi. I'm over to here, 1 over x. X is -1, so we got 1 over -1, which is -1. So we got -2 times -1, which gives us a +2. Secant 3 pi over 2, I'm down to here. We got 1 over x. X is 0, so that's undefined. And back to the starting place, that'll be the same as my first one, which is -2. Okay, so we're ready to plot our points. So here's my 2, and here's my -2. And I think it goes up to 2. And down to -2, if I remember right. Okay, and this is 1, and this is 1/2, and this is 3/2. Well, first point, it says 0, -2. So 0, -2 would be right here. The next one should be undefined. 1/2 undefined, yep. I wish there was a ruler tool on this this program, so I could draw a straight line and have it look like a straight line. Okay, and then our next one should be 2, 1, 2. Yep. So I'll put a point right here. Next one should be undefined, which it is. And next one should be back to our starting place, which was down here, which would be right here. Okay, now knowing what it looks like, I know this is going to come down like that. And this over here If I were to go another half over here by symmetry, this is going to be undefined. Like that. And then this is going to come up, touch that point, and go back down like that. So that right there is our graph. Okay, now let's talk about our domain and our range. Now, when you look at these, the cotangent, the tangent, the cosecant, the secant, they all have places where they're undefined. Specifically, this is undefined at 1/2, 3/2, and -1/2, right here. And if I kept going, this would be 5/2 and so forth. So actually, for our domain, we got x cannot equal to all these values. Well, one way we can do that is we can do n over 2 and say n is odd. So x cannot equal to n over 2. So that means 7/2, 9/2, 11/2. There's actually an infinite number of asymptotes. Now our range. Well, it goes down forever here, then it comes up to -2. So part of our range is going to be from -infinity to -2. Bracket on -2 because it includes that point. And then we're also going to have one up here. It goes from +2 up. So this will be 2 to +infinity. And then union in between. And that would be our domain and range. Now our cotangent and tangent graphs, the domain, we'd have to do something similar, just what you see here. For the range for those is -infinity, +infinity, because they go up, go down forever and go up forever. Let me save this, and we'll look at the next one. There we go. And our last one here is this one. So we got y is equal to 3 cosecant of 4x minus 2. Now I'm going to ignore the -2. So I'm just going to graph the first part. I'm only going to look at this part right here. Then at the very end, I know what a number at the end does. It moves it up or down. So this is going to shift our entire graph down 2 places. Okay, so let's find our period. Period is 2 pi over b. Now b is the numbers for x, which is 4. So we end up with pi over 2. Okay, so let's create our t-chart here. Well, this first one is always 0. This last one is always our period, which is pi over 2. Middle here is always half our period, which would be pi over 4. And then this would be a quarter of our period, which would be pi over 8. Now you could multiply 1/4 times this to get that easily. And then we got 3/4 of our period. This starts at 0, goes pi over 8, 2 pi over 8, or pi over 4, and 3 pi over 8. And then 4 pi over 8, which is pi over 2. Okay, so let's plug that in. So we got 3, this is our y. 3 cosecant of 4 times 0, which is 3 cosecant of 0. This is 3 cosecant of 4 times pi over 8, which is 3 cosecant of pi over 2. This is 3 cosecant of 4 times pi over 4, which is 3 cosecant of pi. And this is 3 cosecant of 4 times 3 pi over 8, which gives us 3 cosecant of 3 pi over 2. These values are looking familiar, aren't they? And 3 cosecant of 4 times pi over 2. is equal to 3 cosecant of 2 pi. Again, those will always go back to your standard x and y axis values. Okay, here's our unit circle. We got our point here, which is 0, 1. Got one here, which is 0, 1. We got one here, which is negative 1, 0. And one here, which is 0, negative 1. And cosecant is 1 over y. Okay, so let's see what we got. Here we got, here's 0. Cosecant is 1 over y. Y is 0, so we got 1 over 0, so this is undefined. Now this one, cosecant pi over 2, I'm up here. 1 over y. Y is 1, so we got 1 over 1 or 1. So this is 3 times 1 or 3. Back to pi here. 1 over y, which is 0, so it's undefined. 3 pi over 2 down to here, we got 1 over y, and y is negative 1, so we got 1 over negative 1 or negative 1. So we got 3 times negative 1 or negative 3. And then back to our starting place, and this is going to have to be undefined. Okay, let's plot our points. So I'll go from 3 to negative 3. So 3 there. And I'll throw negative 3 here. So this would be 1, 2, more or less. And that's negative 1. That's negative 2. And then our period is pi over 2. So pi over 2 is roughly 1.5, which is that distance, which would put it about right here. And then this would be pi over 4. I won't write it down, but this is, well, yeah, I can. Pi over 8. And this one would be 3 pi over 8. Okay, so first point is 0 and undefined. Okay, well, I'll deal with that. So this is undefined here. This means vertical asymptotes. There we go. Next one is pi over 8 and 3. So pi over 8 and 3 would be right here. Next one should be an asymptote. It's undefined. And actually this one over here will be an asymptote too. It's undefined. And there we go. And then this one is going down like that. And then 3 pi over 8 was negative 3. Okay, let me kind of sketch these, what that kind of looks like. So comes down like that, touches at a point, goes back up, and that would be our graph. This one, again, comes up, touches at a point, goes back down, and that would be our graph. Now if we look up here, we said we're going to shift our entire graph down 2 places. So this one here is going to go down 2, which would be right here, which means my graph would look like that right there. So the blue is actually our answer. This one is going to shift down 2. So shift down here, and it'll, again, look like that. And then I would repeat that. I didn't draw that real well, but oh well. We'd repeat that if we wanted 2 periods. So let's talk about our domain and our range. For our domain, see, it doesn't exist at pi over 4. Doesn't exist at pi over 2. That's really 2 pi over 4. This is like 1 pi over 4. And it doesn't exist here, which is like 0 pi over 4. So the next one, where it wouldn't exist, would be 3 pi over 4. And I think you're seeing a pattern. See how these are increasing by 1s? So your domain, x cannot equal to, now we're going to replace the pattern there with n, pi over 4, and then n is an integer. So our range, if I look down here, it goes from negative infinity up to negative 5. So we're going to have negative infinity and then negative 5, bracket on the negative 5, union, and then it goes from 1 on up. So it goes 1 to positive infinity. And that would be our graph and our domain and range. Of course, I don't read directions, but yeah, show at least 2 cycles. So you'd repeat this, the blue part. Okay. There we go. And that's our... Yeah, time for that to blow up, but that's okay because we're done with that little movie, so...